Hello everyone, welcome in another episode of infusion pump journey. So today I want to show you how two pumps are working in synchronized way. So as you can see, both pumps are working together and there is nearly no difference between their working. In last episode I showed you how one pump works. Now we have two, but in the progress there were some problems I had to solve. So let's see what happened. I started with soldering such board. So now microcontroller and stepper motor driver are on a single board, conveniently connected in much more compact way than breadboard. But here I noticed that actually there is no reason to separate this USB port that serves as a connection to motor and end stop connectors because it's just less convenient, more stuff to connect. Therefore, in second iteration, I moved to such 6-pin connector. Now it's much more elegant and convenient. Second problem I noticed was that actually energy delivery became problematic if I have more than one pump. To be able to power all boards with a single power supply, I decided to solder such extension block. Now one power source for motor and one power source for boards is enough, and it should be able to deal with at least 3 or 4 pumps without problem. Another problem I noticed was that pumps were basically not working synchronously, and I checked how lag between server and pump looks like, and what I noticed was that first of all this lag was pretty large because it was in between 50 to 400 milliseconds, and also it was rather unpredictable because it was really changing between somewhere in this range, I said. I were thinking about applying real-time clock, but when I looked at the datasheet of clock I already have in my storage, I found out that error of 2 minutes per 1 year is already way too much, because that means that error will be up to 329 seconds, milliseconds per day. Of course I don't want to synchronize pumps every day. So next idea was to use slave and master relation, where master sends signal to slave that now is starting working, and then both devices are working synchronously. So what's going next? One thing is that I wish to make the programming of those syringes more user-friendly. At this moment, programming is, not attached to easy to understand properties. It's something that makes sense in code, but chemically it's... Another thing is that I wish also to use better parts. Now I'm using those plastic syringes, which, they may be fine for now, but due to elasticity of plastic material, some level of precision is already given up, especially if it comes to stopping and starting. There is some delay. So this is one thing, and another upgrade that probably I will also add in some more distant future will be synchronization, which will be wireless. Now it's wired because project is small, but when it will grow, I wish definitely to use wireless connection. So as a words of ending, I can say that I added link to repository on GitHub, so you can, well, try to replicate this project. And that will be this for today. If you have any suggestion, ideas, or you just want to start some cooperation, don't hesitate and reach out. And that's it. Bye.